Analysis of a diode circuit. Analysis of a diode circuit to find solution. Then here diode circuit V in here resistance connected IR this direction IR here ID these resistance are across the resistance VR across the diode VD total here V out KCL Kirchhoff current law IR equal to this IR equal to ID. Here IR versus VR. This VR versus IR linear. Okay. This portion 1 by R. Here in between in VD diode x-axis VD y-axis ID here current flow like this. It depends upon silicon germanium diode. KVL equal to V in equal to VD plus VR divided by VD plus these are resistance into resistance current. That is, this is equivalent circuit is V in here pull up, here pull up, here pull down. This is V out. So this VR equal to we can say V in minus how much voltage current, how much input voltage, sorry, current, I'm very sorry. VR equal to V in minus VD. V in is the input voltage, VD is the diode voltage. Okay. Here IV characteristics of diode. Current voltage characteristics of diode. ID equal to I not ID equal to this is ID equal to I out I not into e power Vd divided Vt minus 1. This will be the diode voltage. Vt for threshold voltage e power here minus 1. So ID equal to I naught into e power Vd divided by Vt minus 1. Generalized method of finding solution point. Generalized method of finding solution. Graphical method combining pull down and pull up characteristics. Here this is VR equal to V in minus Vd. Here in y-axis resistance current. Here 1 by R in this part. Here 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 VR, okay, IR is minus VR, so minus 1 by R opposite this, okay. Here from here this is minus VR plus Vn equal to Vd. This part minus 1 by R. This is Vn. Here Vn divided by R. Here say this part minus 1 by R. Here in negative side, here positive side 1 by R. Same IR. But here plus VR, here minus VR. Okay. Here in Vd, diode voltage across resistance, current in that resistance in this point Vd solution here only. This is I. Finding solution point, graphical method, continued, rearrangement of full-up characteristic. In this KCL, here actually here HVL, here KCL. So here only solution available. Here this is Vd equal to V out. Here V in. Here IR. ID also here only. In H is KCL, this part. Here diode voltage 1 and 2. Here minus IR. Here for VD1, here this point. For VD2, this point. Finding solution point can name superposition of pull down and rearranged pull up characteristics. Here from this here in this iteration using ID approximately equal to I naught into e power Vd by Vt. Vd equal to Vt ln of Id divided by I naught. Here IR equal to V in minus V out divided by R. This is pull down. This is pull up. Pull down in diode will happen. Pull up in resistance. So this is pull down circuit. in between VD and I, diode voltage and I. This is full up. So here is the point. So iteration using here. Iterative method of finding the solution point. Steps of iterations on superimposed characteristics using IR equal to Vin minus Vout divided by R and Vd equal to Vt Ln into Id divided by I naught. Actually uh, here only the solution. We already have seen the last slide. So this is here pull down. This is pull up. Okay. So step 1 V out equal to 0 divided by Vd equal to Vt Ln of Id 1 divided by I naught. Here this now we will see for pull down only. So V out equal to Vd. V out 1 equal to Vd1. So if for IR 1 for first step equal to V in divided by R. ID1 equal to IR1. These all are step 1 in this iteration. Step iteration imposed characteristics. Okay. And then steps 2 V out. Here I okay, here it told already explained. Okay, V out equal to 0, Vd1 equal to Vt Ln of Id divided by I naught. Okay, steps 2. Here Vd1 V out equal to Vd1. Okay. In this step 2 V out equal to Vd1 1. Okay, finished. Now IR in iteration step 2 IR equal to Vn minus Vd divided by R. It implies Id equal to IR in Kirchhoff current law. Here Vd equal to Vt Ln of Id divided by I naught equal to V out equal to Vd. V out in step 3 V out equal to Vd, IR equal to Id, Vd equal to Vd in step 3. In the same iterative steps to find solution point, numerical exercise of the iteration using equations IR equal to Vin minus V out divided by R and Vd equal to Vt Ln of Id divided by I naught. Step 1, step 2, step 3. Do it yourself and verify the answer. V in 10 volt or 10 kilo ohms, I naught 10 power minus 30 amps, 10 power minus 13 amps, Vt equal to 26 millivolt. Convergence of iterations, numerical observation, step 1, step 2, step 3, IR 1 equal to 1 MA, Vd1 equal to 0.56, 0.59867 volt. Step 2, IR2 0.94013 milliamps, Vd2 equal to 0.597067 volt. Step 3, IR 3.940293 milliamps, Vd2 0.597071 volt. Condition to convergence. Slope of pull up characteristics, slope of pull down characteristics. Condition. Divide. So 1 power 10k here only. Iteration forming dou id divided by dou vd approximately equal to